Let's do one problem, students, which depends upon the principle of homogeneity. While learning about the homogeneity, uh, we discussed that same physical quantities can be added, they can be subtracted, and as well as the divided. Let's remember this rule to solve the problem very easily. Actually, it is a van der Waals equation which has its own tension. Okay, it seems like it's a gas equation. Here in this one, we have to write the physical quantities which are involved in. Here, first one is P. P is what, students? P is pressure. Okay, students. As you know that, directly I am writing the dimensional formulas. Pressure has the dimensional formula of pressure can be written as what pressure is equal to force upon area. The dimensional formula of force is M1, L1, T inverse 2 by L square. Okay, students. And we got the dimensional formula of pressure is M1. I'm taking it up. L inverse, T inverse 2. Okay, is the dimensional formula of pressure, students. It is the equation. It is the equation, dimensional equation. If you write singly, you can say it is the dimensional formula. If you show the pressure on the other side, we call it as a dimensional equation, students. Okay, and second, V. V stands for volume. V stands for volume. And we can write the dimensional formula very easily. The equation of volume, dimensional equation of volume is what volume is equal to L cube, that is M0, L cube, T0. Okay, and here it is the equation. There is no need to worry about the RT. Without using the terms of RT, we can solve this problem easily. Generally, this question looks somewhat peculiar. While we are studying, we are somewhat stressed with the problem, how to solve it. But nowadays, these kind of the problems can be solved very easily if you understand the concept in the right way. Let's say the first part, second part of the equation is where V is equal to minus B. Principle of homogeneity tells us that similar physical quantities have to be added or subtracted. That means what? V might be equal to B. V might be equal to B. Then we can write V is equal to B. That means what? Already we got the dimensional formula for volume. V is equal to M0 L cube T0. Okay, students. We got the dimensions of B, dimension formula of B. It is the dimensional equation of B. Do remember, it is the dimensional formula of B and it is together is the dimensional equation. Let's say the next part. We had P plus A by V squared. Okay, then if you use the same, you can write P by A by V square is equal to constant. In other words, P is equal to A by V square. Only same physical quantities can be added. We are using the same here. Okay, students. Or A can be written as P V square. Okay, students. Already we got the value of the P and as well as the volume here. Then A can be written as P, pressure, M1, okay, L inverse, T inverse 2, multiplied with volume, M0, L cube, T0, whole square. Okay, students, then it can be written as M to the power of 1, L minus to the power of minus 1, T to the power of minus 2, multiplied with M0, L power 6, T to the power of 0. And you learn that when the bases are same, we have to add the powers. Then we can write it as M to the power of 1 plus 0, L to the power of minus 1 plus 6, T to the power of 0 minus 2, and finally M power 1, L to the power of plus 5, T to the power of minus 2, students. It is the dimensional equation of A, a physical quantity A. Okay, students. And it's the dimensional equation. And this part is dimensional formula. Here we have one more dimensional equation. And finally, what is the result? A is equal to what we got? It is m1 n to the power of 5 t to the power of minus 2, and b is m0 l cube. Okay, students, t to the power of 0. It is the desired result, students. He asked us find the dimensional formulas of A and B set. Okay, students, let's do one more problems. Here, now we are going to do one more part of this, that is to check the correctness of the equation. We come across with so many equations and physics students. When you are ninth class, you have learned about these equations. V is equal to U plus AT, S is equal to UT plus of AT squared, V squared is equal to U squared plus 2S kinetic energy, and it is the equation for a wave, and finally it is for the potential energy, students. We took the different types of equations and we are going to check them, are they dimensionally correct or not. Okay, students. Most of the equations can be what's that checked by using the dimensional analysis. I mean by using the principle of homogeneity. Let's start with the first question, students. The first question goes like this. The first one is V is equal to U plus AT. Here in this one, V and U are the velocities. Okay, students. It is V stands for velocity and U also velocity. It is the final velocity and it is initial velocity. Whatever the velocity is the final or initial or the average velocity is velocity sum, students. And you know that the dimensional formula of velocity is what? M0 L1 T inverse. Since velocity is equal to displacement upon time, and you know that displacement is L by T. The same thing I took here. Okay, students, and acceleration. The next one is what? Acceleration. I am writing the dimensional formula of acceleration. What is it? M0 L1 T inverse 2. Since acceleration is equal to velocity upon time. Okay, students. And time is time itself. Dimensional formula of time. Okay, students. It is M0 L0 T. This is the time, students. We have to use these three in this relation. What we have to prove here, LHS is equal to RHS. Then substituting all in the equation V is equal to U plus AT. You can write M0 L1 T inverse is equal to M0 L1 T inverse plus M0 L1 T inverse 2 multiplied with T to the power of 1. Okay, students. And further it can be written as M0 L1 T inverse is equal to M0 L1 T inverse plus M0 L1 T inverse minus 2 plus 1. Then M0 L1 T inverse is equal to M0 L1 T inverse plus M0 L1 T inverse. Together it is 2 of M0 L1 T inverse. Okay, and we can write it as M0 L1 T inverse is equal to M0 L1 T inverse. Okay, here we missed the number here. Numbers don't have any meaning in dimension analysis, students. That's why we are neglecting. With that we can say LHS is equal to RHS. Okay, students. In this way, you can check the correctness of equation, whether it's right or wrong. Then it is the first one, it's over now. We finish it. Let's take the second. Second equation is S is equal to ut plus half at square. Here S is the displacement, students. But displacement directly we can write the dimensional formula. Displacement, dimensional formula of displacement is equal to m0 L1 T0. Here m0 L1, okay, T0. You already got. It is m0 L1 T inverse multiplied with T time directly I'm writing. Numbers don't have any meaning. I neglected. A is equal to m0 L1 T inverse 2 into T squared. Then it can be written as m0 L1 T to the power of minus 1 plus 1 plus m0 L1 T to the power of minus 2 plus 2. And finally we can write m0 L1 T0 plus m0 L1 T0. Where you add, we did the same. It is 2 of m0 L1 T0. Number don't have any meaning in dimension analysis. Then you can write m0 L1 T0 is equal to m0 L1 T0. Dimensionally, it is the correct equation, students. Let's see the third one. Same thing could happen with that. V square. Okay, students. Let's take the fifth equation. It goes like this. Y is equal to a sine omega t. Okay, students. Is the equation of a wave where y is the displacement along y-axis and dimensional formula of y is equal to displacement m0 L1 T0. I think you understood. And here in this one, A is the amplitude. Okay, students, amplitude means it's nothing but length. That is the dimensional formula of amplitude. Is the length. Since it is length, we can write m0 L1 T0. And the third one, it is the angular velocity, students. Omega is angular velocity. This one related to the rotating body, students, or the related to the circular motion. What is the angular velocity we have to understand? The definition can be written as angular velocity omega is equal to angular displacement upon time. And what is the angular displacement? See, students, briefly I will explain. Take it as a reference cycle, students. For the learners, I am explaining these things. Okay, it is the origin and it is the radius. Let's say a particle is at a in a given interval of the time, it reaches the point B, students. That means this radius was that is moving and it came to here. Okay, students. And this one, the theta is known as the angular displacement. Okay, students. Theta is known as the angular displacement. And here, it is the 90 degree, one more 90. In a circle, the sum of all the angles is equal to 360. And this theta is equal to 360. 360 can be written as 2 pi radian. Okay, students. 2 pi radian. The same angle. The particle completed one rotation in anti-clockwise direction and came back to you. Means it completed one rotation. Angular velocity is same. Total angular displacement by time. Here, it traveled distance which is equal to 2 pi radian by time. Okay, students. Okay, students, we got this one. Okay, see, here it can be written as 1 by t. Omega can be written as 1 by t. Since 2 pi is the angle, angles don't have any dimensions, we already learned. Omega is equal to 1 by t. Now I'm substituting this value in that equation. Y is equal to, okay, a into, we are neglecting the sign, it is the angle. Omega t is 1 by t. Okay, students? Yeah, don't ask me where did it go. Here is the t. T get cancels with the t. T get cancels with the t. Then what we had? Y is equal to a. Y is the displacement. See, and a is also amplitude, is nothing but the displacement. So this equation also dimensionally right. These kind of questions are right somewhat twist you, and similar question will be asked like this: Y is equal to a sine v into t. Okay, students, the same result we will get, but forget this: v is velocity, length by time into time. Okay, students. Finally, students, finally we go with this equation. Okay, it is the prop 6. It is u is equal to a root x upon x plus b. Okay, students. Here in this one, u is potential energy, students. X is the length, or you can say it is the displacement. And we have to find out the dimensions of A and B. Okay, students. First, we have to write the dimensional formula for potential energy. Potential energy is the energy possessed by a body by virtue of its position, students. Then you can write it as mgh. Okay, students. Here, if you write the dimensional formula, m1, l0, t0, g is acceleration due to gravity. Any acceleration has the same dimensional formula. That is m0, l1, t inverse 2, and h is the height, height is the length. That is m0, l1, t0. Okay, students. If you go further, we can write potential energy is equal to. Bases are same, we have to add the powers. m to the power of 1 plus 0 plus 0, m to the power of 0 plus 1 plus 1, and 2 t to the power of 0 minus 2 plus 0. Finally, we get m1, l2, t inverse 2. Any energy, maybe it is the kinetic energy or potential energy, whatever the energy is, has the dimensional formula of m1, l2, t inverse 2. Okay, students, and for x we have to write x is displacement. X is equal to m0, l1, t0. Then we are inserting these two values in this equation. First, I am taking this part. X is equal to b. X is equal to b. Means what? B is nothing but length. B has the dimension formula of m0, l1, t0. Okay, students. And A. We have to find out the potential energy. U. I told you it is m1, l2, t inverse 2. Okay, students, is equal to A into root x, root of L, okay, by x plus b, length plus length, length itself, You should not worry about the, what's that, multiplication, students. Here 2L we have to write. Then it can be written as A into root L into L inverse. Or it can be written as A into L to the power of half into L inverse A into L to the power of half minus 1 A of L into, okay students, 1 minus 2 by 2, it is A of L to the power of, okay, minus half is equal to m0 L2 T inverse 2. Then we are bringing it here. A is equal to what you get? m0 L2 T inverse 2 by L to the power of minus half. It can be written as m0 L2 T inverse 2 into L to the power of plus half. You go up and you got plus. And finally, it can be written as m0 L to the power of 2 plus half into T to the power of minus 2. It is m0 into L to the power of 2 plus 2, 4, 5 by 2 into T to the power of minus 2. Okay, in this way, you can find out the constant values also. Okay, students, this is today's part of what's that, dimensional analysis. We learnt about the principle of homogeneity and also how to check the correctness of equations by using the principle of homogeneity, students. If you like the video, please do forward it to your friends and don't forget to subscribe it.